So next is LVDT. What do you mean by LVDT? LVDT means linear variable differential transducer. Okay. So like a strain gauge transducer, we are having linear variable differential transducer. Okay. So usually this is used for translating a linear motion into an electrical signal. Wherever there is a linear motion to the system, it should be converted into electrical system. So this LVDT is having a primary winding. Okay. It is having a primary winding and it is having two identical secondary windings also. Okay. So here this is the primary one and these are the secondary windings. Okay. So this is the secondary winding and this is the primary winding. So this is named as S1, S2. These are wounded over a halo robin. Okay, a movable magnet is there in the middle. So just to move this magnet, we are having an connector. So we can move the magnet. Okay. So S1 and S2 are having equal number of turns and are arranged concretely and placed either side of the primary windings. Okay. So the arrangement is made in this way. So here we are going to give an AC input and we are going to get a differential output of voltage. Clear? So an AC input will be given to this from the primary, an AC input, and we are going to take the secondary output from here. So from here we are going to get the output which is called as differential output voltage. So AC input is there, differential output will be taken, and this is our movable magnetic core. And this is the arm we are using to move this magnet. So obviously there will be a displacement, means the change of place. Okay, so this is how it is. So the primary is connected to a AC source where we have 25 volts and frequency ranging from 50 to 20 Hz. So now the arrangement is like this. They are connected in series, the S1 and S2, and differentiation of output voltage from the secondary windings will be measured. This is how an LVDT is connected. So now what happens? As the core here is moved from left, from its zero position, means null position, there is a magnetic leakage in the secondary windings. So obviously what happens? The winding of S1 increases and S2 decreases because of this displacement. So the core inside the secondary winding in S1 increases and that in secondary winding S2 decreases. Therefore, the output voltage induced in the secondary winding of S1 increases, whereas the output voltage induced in S2 reduces. Secondary windings, as they are connected in series, and that from there only we are taking the output, so it is giving us an differential output voltage. This is how we are using an LVDT. So you should talk about the structure of it and the operation of it. The structure is we are having two secondary windings and one primary winding. S1 and S2 are of the same number of turns, and we are keeping an iron here which is a mobile one, and we are giving an AC input of certain voltage like 25, and then we are trying to move the magnet. Then there is an action. Obviously because of this the number of turns in S1 are increasing and S2 is reducing. So as S1 is connected to and S2 is connected to the output, when we are checking we can see that the output voltage of S1 is increased, output voltage of S2 is decreased, and when S1 and S2 are in series, when we add them, that will give us the basic output voltage, which is an differential output voltage. This is called as LVDT, the linear variable differential, the linear variable differential transducer.